Now, this O minus should go and attack over R prime, making this X to leave. So from here sodium, from here X, NaX is lost. So minus NaX, and reaction should proceed via SN2 mechanism. So product will be R, O, R prime, either. Right? Any questions are in it? No. If it is in case of alkyl halide, alkyl iodides will react more readily than alkyl bromides, than alkyl chlorides, than alkyl fluorides. Reason? Bond cleavage occurs readily. And Ri bond will break readily, no? So Ri will react more readily than RBr, than RCl, than RF. If it is a primary, secondary, tertiary, SN2 reaction. So it should react with nucleophile readily. Primary. So in case of alkyl halides, primary alkyl halides more reactive than secondary than tertiary. Right? Now, this is alkoxy group. Here also, this may be primary, maybe secondary, maybe tertiary also. In case of SN2, crowding will play a role. So, which will react with alkyl halide readily? Primary alkoxide or secondary or tertiary alkoxide? Which will attack over alkyl halide readily? The crowding, man, if branching increases here, then repulsion increases, so it cannot go and attack. Or if it is tertiary, butoxide, bulky nucleophile or bulky base. Bulky bases prefer to show elimination, not substitution. So alkoxide also, what type of alkoxide will react readily with alkyl halide? Primary will be more reactive than secondary. Tertiary almost not at all reactive, right? So in case of alkoxy also, primary more reactive than secondary more than tertiary. Right? As reaction is proceeding via SN2 mechanism, all the conditions which favor SN2 mechanism favor Williamson the ether synthesis also. Right? What are the conditions favor SN2 mechanism? less hindrance, less steric hindrance, right? Less steric hindrance. What type of solvent? Polar aprotic solvent. Correct or not? Better, I will leave here because remaining all conditions are SN2 conditions. Response or any questions in it? Example I am taking. CH3, CH2, ONA allowed to react with CH3Br. What should be the product? CH3, CH2, OCH3 plus NABr. Acceptable, sir? Another example. O minus Na plus, sodium phenoxide, allowed to react with CH3, CH2, Br. Product will be ethoxy benzene, correct? Huh? Now, observe this note. Observe this note. CH3, CH2, ONA will not react with this one. Now reaction will not occur. Observe this and this carefully. Here phenoxide will go and attack. Then you got ethoxy benzene. Here also what do we expect? This will go and attack. Here also we will expect CH3, CH2, O, phenyl ring plus NABr. We should expect this one, no? But here reaction will not occur. Reason? Aryl halides, vinyl halides. On those on phenyl halides and vinyl halides, SN2 fail. Reason? Anti-periplenarity condition fails. Na? Br is leaving group. Incoming group should be exact 180-degree angle apart. So this cannot go and attack over this carbon, right? That's why this reaction do not occur. So better I will remove this and I will say no reaction. Why no reaction means? SN2 fail. Acceptable, sir? Online. Respond.
Yes, sir.
Sir, can you explain why again?
See this. Over any substitution, for example, I am taking CH3Br and a nucleophile. Nucleophile should go and attack here and Br should leave. Then only SN2 will happen. Then Br minus gone out. And here you will get CH3 and that nucleophile will form a bond. This is the condition for SN2 mechanism. On benzene ring over this carbon, on the back side total benzene ring is present. How this nucleophile will go and attack over that carbon at an angle of 180 degrees? Not possible, no? Because that side Br is there, this side total ring is present. So attack over that carbon is impossible now. It is not free. So SN2 fails. Understood or not?
Yes, sir.
I am taking one more example. CH3C, CH3, CH3, O minus, Na plus. Sodium tertiary butoxide allowed to react with CH3Br. Instead of CH3Br, here also if you take tertiary alkyl halide, then also no reaction. Reason? Here instead of CH3Br, if I take CH3C, CH3, CH3Br, now reaction will not happen. Reason? This is bulky.
Crowding.
Here also bulky group. So this cannot go and attack here. Right? Now what can be the product? If these two are allowed to react, this will go and pull H plus out. Here, this will go and pull this H plus out. So converts into alcohol. This bond will shift here, Br will be gone. So and this will convert into alkene. Are you able to understand? If this is a sodium tertiary butoxide and this is a tertiary alkyl halide, then you will get alkene instead of either. Are you able to understand? Now, that's why I have taken smaller group here. So product will be CH3, C, CH3, OCH3 plus NABR. Any questions, sir? Are you able to understand or not? Do you have any questions?
No, sir.
I am taking one more example. Br 1, 2, 3, 4, 5, O minus, Na plus. Now, what can be the product? Alkoxide is present in the molecule. Alkyl halide also present in the same molecule. So within the molecule, Williamson either synthesis is possible, na? Alkoxy group is there, alkyl halide is there. So we call it as intramolecular Williamson synthesis. Or can I say NGP, neighboring group participation? Within the molecule, a group adjacent to it is attacking, right? Now tell me the product, sir. This will go and attack here, making Br to leave. So NaBr is gone. What is the size of ring now? With including oxygen. 1, 2, 3, 4, 5, 6. So can I get oxygen? Response, sir. Now I am taking one more example. Now tell me the product, sir. In case of SN2, what should be the condition? Anti-periplanar. So if a Br is towards us, nucleophile should come from behind. So Br is above the plane means this OC2H5 must be below the plane. So the product should be. What should happen? Here I should get O ethyl. Now hydrogen comes to above the plane, correct or not? Walden inversion. Are SN2, man? If it is R configuration, product should be S configuration plus NaBr. Example, sir. I am taking one more example. CH3ONA allowed to react with CH3CCH3. Oh, okay. Now tell the product, sir. What will be the product now? What is this? Bulky alkyl halide. Then do this methoxy group can go and attack over this carbon. So what it will do? It will go and pull H plus from here. So the product will be CH3OH alcohol plus alkene. Note. This will not show involve in either formation. Acceptable or not? Br is here. Then alkoxy group should attack from backside. Impossible, no? Correct? So SN2 fails. So either formation doesn't occur. So this alkyl halide will not involve in Williamson ether synthesis. In the same way, in this case, fails or not? Next. In this case, we discussed now just now, wherever SN2 fails, Williamson ether synthesis also fail. Phenyl halides, vinyl halides will not involve. So here there is no crowding, na? Or Br is that side, so nucleophile can attack. Then why you are not doing here? Bromine's lone pair can involve in resonance. So then what happens to between carbon and bromine? Double bond character. Correct? So because of that, is it possible to make that Br to leave? Not possible. So again in vinyl halides also, SN2 fail. Now, in case of tertiary halides also SN2 fail. Here also Williamson ether synthesis fails. Reason? This is primary only. But here also Williamson ether synthesis doesn't occur. Reason? This group is bulky. Therefore, this will repel incoming nucleophile. So here also fail. Etc. Will not show Williamson ether synthesis reactions. Any questions, sir, in this? Acceptable or not? Respond. Next one, sir. So we are done with one type. Preparation of ethers from alkyl halides. We discussed about two things. One is Williamson ether synthesis. Second one, by using silver oxide. So I'm talking about second reaction. By using silver oxide. Now see this example. 2Rx plus silver oxide on heating. What silver do? Silver will remove X to form AgX. So 2 moles will remove 2 X's from 2 alkyl groups. Then what is left? O and 2 R groups. So product will be R, O, R and 2 AgX. Acceptable, sir? Correct or not? Any questions in this? I'm taking one example. 2 moles of ethyl iodide allowed to react with silver oxide on heating. Then what you will get? Diethyl ether plus 2 moles of AgA. Now see this one. If I take a chloroform or iodoform, if it is heated with silver, now tell me what should be the product, sir? Now tell me, sir, what should be the product? Correct. 6 moles of AgA is lost. So you'll get 3 bonds between carbon and carbon. So what you will get? Alkyne. This alkyne, instead of heating, the same if got heated over iron, then what will be the product? Benzene, because alkyne reacts with, undergoes cyclization over red hot iron. Correct or not? So here I will write CHI3 now what I will write as a product? Then I will write benzene as a product. Response, sir? Correct? Whether I will write benzene as a product or on benzene, can I write CHI2 as a product? I got benzene, no doubt. Alkyl halide in presence of iron reacts with benzene, electrophilic aromatic substitution. CHI3 again reacts with benzene, na? So then what you will get? CHI2 plus will go and attack over benzene. Okay, we don't think much. Better I will stop the reaction here. Okay, va? So here what I will write? Instead of 6 moles, how many moles I will take? 12. 12, 18. 3 should be there. So 3 means 3 means totally 6 carbons must be there, man. Means here also I have to take 6 carbons. Yes or no? Each carbon is having 3 iodines. Now silvers will be 18. So instead of writing this, can I simply write these two as 1:3 ratio? Over or not? Response, sir? You will get benzene over. Clear? So we are done with preparation of ethers from alkyl halides. One is Williamson ether synthesis. Second one by using dry silver oxide. Or if it should not be moist silver oxide, sir. If it is moist silver oxide, what happens? If it have beta hydrogen also, Hoffman exhaust 2 methylation, forming alkene, Hoffman alkene. Let's see this. What happens if it is moist silver oxide? This acts as a good base. What base will do? Pulls this H plus out, then this bond will shift here, and this will be eliminated. Correct? Huh? And this is base, man. Okay, wow. So what you got? Alkene. Right? That's why it should not be moist silver oxide. That is the reason I'm heating. So it should be dry silver oxide. Then only you will get either. If it is moist silver oxide, it may lead to formation of alkenes. Any questions on this online? Someone respond. You have any questions on this?
No, sir.
Next slide, sir. Third reaction. We have seen two preparation methods. Now we are seeing the third preparation method by using diazomethane with alcohols and phenols. Third reaction. A reaction of CH2N2. We call it as diazomethane with alcohols or phenols. What diazomethane do? If I heat diazomethane, N2 gas escapes out. If N2 is gone, what is left? CH2 and empty orbital, carbene. Correct? So diazomethanes are good sources of carbene. So now see the reaction. Alcohol with CH2N2 in presence of Lewis acid. Why I am writing BF3 as Lewis acid? Boron is electron deficient or not? So followed by heating. Then N2 gas escape out. N2 gas is gone. So what is left? CH2. That mechanism also will show 1 minute. No, show that mechanism. Alcohol acts as a lone pair electron donor. Though alcohol can act as a lone pair electron donor, boron has empty orbital, so it will accept. So it leads to formation of ROH, coordinate bond, BF3. This will convert minus, and here you will get plus. Acceptable, right? This is now allowed to react with CH2N2. I am writing that CH2N2 in this way. CH2 double bond N minus plus. Can I write like this? Or I will write like this also. CH2 minus. I will make this to shift and this to shift. So CH2 minus, single bond N, triple bond N, lone pair and positive charge. Can I write like this also? So I am using this term. CH2 minus, single bond N, triple bond N, positive charge. Now can I say this acts as base and can go and pull this H plus out? Possible or not? Then what should be the product? RO BF3 minus, positive charge over oxygen got lost because H plus is pulled by. So it converts into CH3 bond N, triple bond N plus. Now can I make this oxygen to donate lone pair of electrons to carbon, making N2 to leave? This oxygen can donate lone pair of electrons because boron is already electron rich. Oxygen is also having lone pair of electrons. Then what happens to electron density over oxygen? Enhances. So it acts as a good nucleophile. So it will go and attack, making this N2 to leave. So then what you should get? What you will get now? I am writing this as BF3 plus RO minus. Is there anything wrong? I am writing this as BF3 and RO minus. Now this RO minus will go and attack over this, making this N2 to leave. So the product will be. What will be the product now? ROCH3. N2 is lost. BF3 is lost. Response, sir. So what you got finally? Ether. Correct? Huh? So what should be the product here now? Respond. ROCH3 plus En2. BF3 is involved and finally produced also. Right? I am taking one example. CH3, phenyl ring and OH allowed to react with CH2N2 in presence of BF3 followed by heating. Tell the products, sir, now. What will be the product? You got CH3 group here. So product will be 4-methyl anisole, correct? Huh? Plus N2. Next, by using Grignard reagent, sir, fourth reaction. Formation of ethers by using Grignard reagent. Now, see this one. Alcohols are allowed to react with Grignard reagent in presence of dry ether. What do you will get, sir? What do you will get? There is acidic hydrogen, right? If acidic hydrogen is there, what this R prime will do? Takes that H plus. So it converts into R prime H alkane, correct? Plus Mg or X. So what you got? Alkane as a product. That's why instead of taking alcohols, we are taking ROCH2X. So we call it as halogenated ethers. Like halogen possessing ethers, right? Halogenated ethers. Do they have acidic hydrogen? Do they have acidic hydrogen? If O is having hydrogen, then it is called acidic hydrogen. Hydrogen is present over more electron into atom. Hydrogen is not present over more electron into atom, right? Now this is allowed to react with CH3EMGX. What you got? This is a good source of R minus, means CH3 minus. Now CH3 minus will go and attack, making this X2 leave. SN2 mechanism again. Correct or not? So product will be ROCH2. Over that you got CH3 plus MgX2. So what you got? You are getting higher ethers. Are you able to understand why I'm writing it as higher ethers? Here, over oxygen, you have only one carbon along with R. Here, you got two carbon chain. So carbon chain enhances, right? So halogenated ethers with the Grignard reagents produce higher ethers. Next. Formation of ethers from alcohols. Already we have seen formation of ethers from alcohols and phenols by using BF3, right? Now, acid catalyzed reactions with alcohols. Fifth reaction. Dehydration reactions. Generally, dehydration of alcohols lead to formation of alkenes. Response, sir. Right? Dehydration of alcohols generally leads to formation of alkenes. But at a temperature of 140 degrees centigrade, if temperature is 110 degrees centigrade, already we discussed it. Ethyl alcohol at 110, sulfonation product. At 140, ether. At 170 or greater than 170, alkene. That is dehydration only, na? Right? So this. 2 moles of CH3CH2OH. At temperature approximately 140 degrees centigrade. Now what you will do? By taking 2 moles, I will remove H2O. I am removing H2O. Is it dehydration or not? So lead to formation of ether, right? So at 140 degrees centigrade, first I have to add dehydrating agent also. What is the dehydrating agent? Sulfuric acid, right? Online, respond.
Yes, sir.
Any questions?
No, sir.
Now see this. If it is a tertiary alcohol, reaction will proceed via E1 mechanism by forming carbocation. If it is a primary or secondary, reaction will proceed via E2 mechanism or maybe SN1 mechanism, right? So here reaction will proceed via either SN1 mechanism or E1 mechanism. In case of secondary, tertiary alcohols. Whereas with the primary, follow SN2 pathway. Any questions in it? See why I am saying that as a primary will follow SN2 pathway. See this. You are adding acid, right? Alcohol first react with that acid to form OH2 plus. Acceptable or not? Right? H2O will not leave. Reason, if it H2O leaves, you will get primary carbocation, unstable. Now, second molecule of CH3CH2OH will donate lone pair of electrons, making this to leave. What is this mechanism? SN2 or not? So then what you will get? H2O is gone. So you got CH3, CH2, OH, CH2, CH3 plus. Later this H plus is lost. You got either. Respond, sir. What is this mechanism? SN2 or not? That's what I am writing. Primary alcohols follow SN2. If it is secondary or tertiary, will follow either SN1 mechanism by forming carbocation or even elimination. Right? Any questions in it? We are taking one example. No need to discuss about ethyl alcohol no? At 110, at 140, at 170. Right? Now tell the product, sir. Tell the product. What happened? What happened? Both are primary. First H plus will go here, forming H2O plus. Then oxygen will donate lone pair of electrons from here to here. Correct? If I take a little lesser. Now, 6-member ring. 1, 2, 3, 4, 5. Oxygen, including oxygen, 6-member ring. Otherwise, including oxygen, 7-member ring. Right? Now, what you got? Oxirane. Respond. Any questions in it? I am taking tertiary alcohol with concentrated sulfuric acid at 140 degrees centigrade. Now tell the product, sir. What happened? You will get alkene instead of ether. Reason? Elimination, even mechanism is powered. And you will get no doubt carbocation only. Right? So instead of going and attacking over that, it will try to pull H plus out. So reaction will proceed via even mechanism. So product will be alkene. Now I am taking one more example. Instead of tertiary, I am taking secondary. Again with concentrated sulfuric acid at 140 degrees centigrade. Now, compared to this, hindrance is less. Now, definitely carbocation is possible. As crowding is less, substitution is also possible. And of course, elimination is also possible. If it undergoes elimination, I will get alkene. If it shows substitution, I will get ether. Both are possible or not? Right? Now, which becomes major means elimination becomes major. Substitution will be minor. If it becomes primary, then substitution occurs readily. That's what I have written here. SN1 or E1 preferable in secondary and tertiary. Here we are heating. Heating means elimination is preferred. So what happened? E1 becomes major. If it is the primary, SN2 becomes major. Clear? Any questions, sir? Online? Any questions?
No, sir.
Next one. Catalytic dehydration. Sorry, catalytic dehydration. alcohols heated in presence of Al2O3. Then you will get ROR plus H2O. Catalytic dehydration. And in case of dehydration, we have discussed KHSO4, P2O5 on heating, anhydrous CaCl2 on heating, concentrated sulfuric acid on heating, H3PO4 on heating, Al2O3 on heating. All these are dehydrating agents, right? So one example. Product. Can I diethyl ether? Response, sir. Any questions in there? Next reaction, sir. Addition of alcohols to alkenes. Why I am writing this separately? Because already we have seen that reaction. What is this one? This is alkene. We are adding alcohol. So addition of alcohols to alkenes form ethers, right? That alcohol will donate lone pair of electrons to more substituted, more stable carbocation position. Correct? So we are writing the same. Addition of alcohols to alkenes. So example I am taking directly. What we call this one as? On benzene, if you have double bond, what do we call it as? Styrene. Now styrene is allowed to react with dilute H2SO4 and you are adding methanol. What you will get? First H plus will go and attack. If H plus attack, you will get benzyl carbocation. If you get positive charge here, it is stable. Then methanol will donate lone pair of electrons there. So product will be you will get O methyl group there. Acceptable, sir? Next. Synthesis of epoxides. We call epoxides as cyclic ethers. Correct? Huh? I am writing CH3, CH, double bond, CH2, alkenes in presence of peroxides. Either I will take H2O2 or R2O2 or MCPBA. What is this MCPBA? Metachloroperbenzoic acid. Here, if I write COH, benzoic acid. If I write COOH, perbenzoic acid. If I take chlorine here, metachloroperbenzoic acid. All these are peroxides. Now you will add oxygen over it. So product will be CH3 CH OCH2 epoxide. Done, sir. Any questions in this? Now one more thing. This epoxide in presence of acid, if I add water. So I'm writing H2O in presence of H plus. Same peroxide, epoxide, allowed to react with water in presence of base. Now water. We call this as acid catalyzed cleavage of epoxy bond, base catalyzed cleavage of epoxy bond. Now, first the H plus will go and attack over this O. Or I am adding acid now. So first H plus will go and attack over oxygen. If H plus will go and attack, what happens? You will get CH3, CH, O, CH2, H, positive charge. Correct? Huh? Now tell me whether this bond prefer to cleave or this bond will cleave. Left one. It means it is trying to form more stable carbocation. So reaction will proceed via more stable carbocation. And then water will donate lone pair of electrons to that carbon. Correct? So I will write CH3, CH, positive charge, CH2, OH. Now water will go and attack over there, forming. So I will write like this. Directly I am writing the product, sir. Can I write both OH groups are added on opposite directions? You got epoxide here. You will get OH here. Bond is cleaving. Then water is donating lone pair from the other side. Correct or not? So can I call it as anti-hydroxylation? Addition of two OH groups is called hydroxylation. Now two OH groups are added on opposite direction. So I call it as anti-hydroxylation. Right? I will do one thing. In order to avoid confusion, I will write like this. Will you understand, sir, what I'm trying to write? Respond. I'm trying to donate lone pair of electrons of oxygen to more substitute carbon. Right? Now observe this, sir. If it is base catalyzed, what should happen? If it is base catalyzed, what should happen, sir? First, OH minus should go and attack. Whether it will attack on secondary carbon or primary carbon. Now it acts as nucleophilic. And OH minus acts as a nucleophile. So nucleophile should go and attack on less hindered carbon. Na? Are you able to understand? There H2O is attacking on more substitute carbon. Here OH minus is attacking on less substitute carbon. So I am going to write that here in this way. Will you understand now? Here also, of course, product is anti-addition product only. Here also you are getting both OH groups on opposite sides. But here water prefers to donate lone pair of electrons towards more substituted carbon. Here OH5 minus will go on attack on less hindered carbon. Right? Sir. Yeah, yes, sir. ఇంకొక 5 minutes. సార్ ఇది వెంకటేష్ సార్ దగ్గర సార్ వెంకటేష్ సార్ దగ్గర ఓకే మరి ఇంతవరకు ఎగ్జామ్ జరగలేదు సార్ అదంతా పేజ్ పోలేదా Any questions, sir, in this? Now I'm taking one more example. CH3, CH, CH2, O. I have taken epoxide, allowed to react with HX. Tell the product, sir. First H plus will go on attack over oxygen. So you get OH positive charge. Now X minus should attack on which position? Less substituted carbon or more substituted carbon? What happened? Where X will go on attack? When you get OH here, you are getting positive charge, no? Then this tries to pull bond towards it, no? Then it prefers to form primary carbocation or secondary carbocation, which is preferable. Then X minus should go and attack on. That's what I told in case of acid catalyzed. Here also water acts as a nucleophile that goes to attack on more substituted carbon. So what should be the product now? CH3, CHX, CH2OH. Next, ROH, alcohol. If it is allowed to react with alcohol, now what should be the product? This is also acidic hydrogen only. Alcohol's hydrogen is also acidic only, na? Right? Now OR goes to more substituted carbon. So again, product will be CH3, CH, OR, CH2OH. Now, next one. D plus D2O. Now tell the product, sir. D plus will go and attack on O. Then D2O, oxygen has to donate one pair of electrons to. Again, more substituted carbon. Correct? So product will be CH3, CH, OD, CH2, OD. All are anti. I am taking one more example, sorry. OH minus H2O. Now tell the product, sir. OH minus will go and attack on which position? Either tertiary carbon or secondary carbon. On which carbon that OH will go and attack? Secondary. If it attacks on secondary, this O18 will be present on tertiary carbon. So product will be here I will get OH, that is 18. Here I will have OH. Response, sir. Correct or not? Next one. Sodium ethoxide in presence of ethyl alcohol. Sodium ethoxide in presence of ethyl alcohol. Now tell the product, sir. Again, and this is also bulky, so it prefers to attack at. So product will be it will attack here O ethyl. Here what I will get? This will attack here. You will get O minus. From ethyl alcohol you will get H plus. So it will convert into OH, O18H. Correct? Huh? Respond. Now I am taking Grignard reagent. CH3 MgBr. Followed by hydrolysis. What do you get now? CH3 minus means again nucleophile. Nucleophile preferably attack at less hindered position. So product will be that CH3 group attacks here, correct? Huh? Here again I will get OH, O18. Any questions? If I add ammonia, then what will be the product? Here also nitrogen acts as a nucleophile. On which position nitrogen will donate lone pair of electrons? Less hindered. So you will have NH2 at less hindered carbon and OH on more substitute carbon. So product will be NH2 here, bond here OH, labeled oxygen. Any questions, sir? Online respond. In presence of base, they will always prefer less hindered carbon. If it is acidic, it will go to more substituted carbon. That's all. So we are done with the synthesis of epoxides. Now, next is heading, sir. Physical properties. Here I am writing. I will stop today's discussion. We will continue on next class. All right, today we will roll out one what we call it as one poll, right? So try to give your reply in it. We will find it out and we will take the action accordingly. Again, I am saying this poll is related to Monday, Tuesday, Thursday. These 3 days. We will teach only topics related to boats. For example, I am discussing about alcohol phenols ethers chapter. This it is not yet completed, right? So I will pick out important questions from your boards related to the same chapter, right? Objective type questions. That's what I am saying, right? Objective type questions, 2 mark questions, 4 mark questions. What are the important things related to this chapter? Only we will discuss on Monday, whenever I have chemistry class, either Monday or Tuesday or Thursday. If I am getting classes on Friday, Saturday, Sunday, then what I will do? We will proceed for numerical solving related to JEE Mains or JEE Advanced. Is it clear? Means indirectly you will have classes on every day, weekday as well as weekend, starting from tomorrow. right? But Monday, Tuesday, Thursday, we will discuss purely things related to boards, right? So even if you miss, you will not lose much because we are doing only board related things, right? So that you should not have any choice of saying, sir, we are not getting board support. We are giving board support also. Okay, wow. Right? I think alternate days. Yes, sir. Please update link in Gmail. Yes, sir. We'll post in your WhatsApp group itself. Every day we'll post links in your WhatsApp group. Right? Okay, I will end the session then.
Sir, no.
No, notes I will post. I will post.
Okay, sir. Thank you, sir.
Right. Hardly it will take one more lecture. We will complete either spot. We'll solve some numericals and I will go to next chapter, that is aldehydes, ketones, carboxylic acids. Most part of aldehydes, ketones, carboxylic acids is over except Nemood reactions, right? But anyhow, we will discuss slowly. Once that is done, target 4 is also will be over. Target 5, biomolecules already over. Only amines left. Hardly it will take 2 classes to complete target 5, right? Means within a week, I will move to target 6. In target 6 already, surface chemistry is over. Say something, yes or no. Then polymers, chemistry in everyday life, practical organic chemistry, metallurgy, qualitative analysis. 5 chapters are there. All these 5 are deleted portions. Only 1 chapter, qualitative analysis, related to your practicals, right? So only deleted portions will be left. Means indirectly, if I complete 2 chapters, your syllabus of class 12 JEE mains will be over, right? There is some feeling like syllabus is over is good, na? Right? Okay, carry on. You can leave.
Sir,
Yes, sir.
can we come and get our books on Monday?
Yes, you can come and get your books. Once you drop a message to that EDP or someone, yes, sir. To branch people, you drop a message, they will keep the books ready.
Thank
Yes,
you,
sir.
sir.
Yes, sir. Bye, sir.
Thank you, sir.
Yes, sir.
After this, parallel services will come up.
Huh.
Parallel services will come up.
If you want, I will ask him to come.
Yes.
Your choice.
All of us have been shaken.
I will ask him to come on Sundays, at least Saturday, Sundays. Possible. It depends upon demand and supply.
Okay, sir.
Which
Thank you,
topic? Optics is going on.
Sir, after this chapter, optics is about to start, sir.
So for optics, you want Chiranjeevi sir, huh? After this, modern physics.
Yes, sir.
I will plan. First, let me check out the timetable.
Okay,
I
sir.
will plan.
Thank you, sir.
Yes, sir.
And sir, about
Yes, sir.
the extra classes, sir.
Hmm.
Since I feel like I don't need help with my board, it's not in the game, sir.
No need. Then directly you can attend on Friday, Saturday, Sunday.
Already morning to evening, day books here.
Yes, that's right. It is not for everyone.
Nice.
For slow learners, for them. Right?
So then on Saturdays and Sundays as usual.
Friday, Saturday, Sunday.
Friday, yeah.
Friday, Saturday, Sunday.
Friday
As
just like
usual.
Saturday, 5:30.
Right? For weekday as well as weekend students, completely on Friday, Saturday, Sunday. Common for everyone.
Thank you, sir.
Yes, sir. Yes, sir.